This project is on thermal propulsion rocket with thrust vectoring. We have team members Drew Asche, Tyler Dahle, Jacob England, Allison Fawver, and Daniel Paulus. Our project mentor is Dr. Jordi. We're sponsored by NDSU. Our design goals are to have 2 engines with thrust vectoring and the ability to throttle. Each engine has 2 newtons of thrust and a specific impulse of 150 seconds. Thermocouples at multiple locations and PIV support can be used for data analysis of the engines.
The rocket has a tube and flange design. This design allows for easy assembly and also for easy maintenance if a problem occurs inside the rocket engine. A quick connect coupler was also in the design to allow for easy connectability to the nitrogen gas. The rocket body was also made from stainless steel, and the heating coil is made with nickel chromium wire. A layer of insulation was used to protect the nickel chromium wire from shorting out onto the rocket body. The rockets were mounted onto an optical bench and connected to a vacuum chamber for testing.
Jumping into the detailed design and analysis of the engine, a MATLAB script was utilized to determine the necessary dimensions of the nozzle. The method of characteristics was then utilized to design the contour of the diverging region of the converging-diverging nozzle. CFD was utilized to confirm the results from analytical methods, ensuring choke flow occurs and approximate nozzle exit velocity was achieved. Boundary conditions for this CFD model included inlet flow rate, exit pressure, and temperature at the inlet. CFD of the thermal chamber was also conducted to ensure the temperature of the nitrogen reached the desired temperature of 1000 Kelvin. The initial concept failed to meet design criteria due to inadequate heating at the center core of the flow. To remedy this issue, the initial thought was to decrease the diameter of the flow chamber. Although heating improved, it wasn't enough. The next concept was utilizing a variable diameter coil to improve flow mixing and heating in the center. This concept successfully heated the flow and was chosen as the final design.
And this is the general setup for our experiment. A rocket is fed with 15 psi of nitrogen in the inlet and is fed through a heated coil and exits out of a 3D printed converging diverging nozzle out of stainless steel. This nozzle exits into a vacuum chamber that will be under vacuum and is on linear guide rails to measure for force.
After the rocket was successfully assembled, we began testing. In this clip you can see one of the initial fires as we prep all the systems for the first test. A big thanks to Dr. Jordi for all his help and input throughout the process. Also for Porter and his support regarding questions about previous designs, Charles for his assistance in the CFD setup, Rob Saylor and Frank in their support in manufacturing, and a big thanks to the NDSU Mechanical Engineering Department for their generosity in this project.